So far, we have defined the static part of our specification, namely the imports over here using extents, and also the constants, and also the associated axioms, which we don't have to prove, but rather we can assume and take them for granted. And remember from 3342 the principle, whenever you want to formally model a system, you have to model two parts, the static part and the dynamic part. The dynamic part will actually consist of things like variables and also properties that you want to actually check against your system. That's something we'll do gradually. Let's now try to define the dynamic part in our specification, in our module over here. And there is a special syntax you will actually have to remember, that in TLA plus, whenever you want to start the algorithm, which will be the dynamic part, you have to surround it within certain special symbols corresponding to the multi-line comments. If you remember the multi-line comment symbol, round parenthesis, star, and also star, round parenthesis. That's what you're going to do. Okay. So first of all, let me just write a single line comment here for you. So here we model the dynamic part. Dynamic. And you gotta make sure you don't make any typo. I don't think usually the spell checker will be in effect for the TLA plus tool. The dynamic part of the module, which will be the algorithm. And the way to do it will be, we want to start a multi-line comments. Round parenthesis, star, hit a new line, star and closing parenthesis. That's what you need. And whatever you put inside over here will be treated as the algorithm. And just notice that this part over here will be translated into the TLA transition system. I'll write it down over here. What's included in the algorithm will be translated. Of course, you have to hit the translate button yourself. Translate it into TLA, state machine. And that's something I will explain to you, how to interpret the generated state machine once we have developed the algorithm. And what should we put over here? And let's recall ourselves again, the model over here. And I would suggest I will just develop all the syntax you will need. So I can just try to cover as much as syntax as possible. There might be certain missing symbols which you will be expected to really go into the resources that's really linked from your lab manual and to do a little bit self-study yourself. That would be something I would expect from you guys who are already in the 4th year. Okay, do some parts from your end. I'll do as much from my end as possible. All right, and let's see what we should do. And let's first declare that we're going to define some algorithm. So you have to type verbatim over here. Dash, dash. Oh, sorry. Let me just make sure it's focused. Dash, dash. Okay, single dash, dash, no space. And then spell the word algorithm. Okay, make sure you spell it correctly. And if you spell it correctly, you will see some syntax highlight over here. Okay, and actually very usefully, if you move your mouse over, it also show you the kind of the syntax of the algorithm. But I would say if you find it useful, it might be good, but you might find it not very user friendly. That's okay too. It's up to you. It's something that's kind of equipped with the TLA plus tool. So once we spell the algorithm, put a space, and let's give a name to the algorithm. So here we don't need to come up with any fancy name. We can just come up with, maybe just use the same name as the module. That's okay. Usually we have only a single algorithm for each module. So it could be just bridge controller, but now rather than using underscore, we can follow maybe the more Java convention for the method, similar. Okay, so bridge controller. Over here, you can say M0. That's one way to do it. Or if you want, you can say underscore M0. So the naming convention here, if you're just developing your own project, or if we explicitly give you freedom, you can use whatever name you like. But sometimes you might be restricted about what names you can use. Just watch out for that. Right? And then the way we're going to enclose the body of the algorithm will be just like a methods in Java. So a pair of curly brackets, and then hit enter over here. Right? So whatever that goes inside, starting from line number 20, will be the algorithm itself. I'll try to summarize about the structure of the TLA file that you will need for a typical example. I'll do that maybe at the end of, well, actually after we have show you all the syntax for this week, right? I'll talk about it. Right, so what should we do? First of all, let's do variables. Okay, so I can type variable over here, and notice that variable here is singular, not variables. No, not really. So let's say we want to have definitely the variable n indicating how many cars have been on the bridge or on the island, for sure, and in the complex. But I would like to introduce one more variable over there called I, and I'll show you how to interpret I in a moment. But let's say, how do we define variable? They will be separated by comma, and if there's any initialization you want, optional, you can also initialize a variable right away. Very similar to how you would do in the C programming language, maybe back in your ECS 2031. So I would say variable n, declare that, and then I want to initialize that to be 0 at the same time. And comma, that's the first variable. And then second variable I, initialize to be 1. And put a semicolon, right? So this is our very first variables for the algorithm, right? But you have to make sure all the variables are declared in a single section, right? That's kind of the syntax requirements. You cannot really do like an interleave variable declaration. I don't think that's allowed in TLA plus tool. Right, so that's two variables here, and we want to somehow convert ML out and ML in. They are individual events, so the closest correspondence in TLA plus or Pascal dialects, right? Remember we talked about the Pascal, and if you want to actually find out more, you can look at the Pascal tutorial yourself. I'll try to give you guys more guidance, maybe it's more specific section, the minimum that you should really look at. I'll include it in the lab manual, okay? But for the Pascal, the closest correspondence to events over here will be procedure, like a method, okay? So you got to type out the word procedure. So we're going to have one procedure called ML out, the other procedure called MLN, and then in the main program, in the main control, we're going to call MLN and ML out in an interleaving bounded way. That's something I will show to you, right? One thing at a time. And of course, if you want to maximize the tab, you can also double click on that if you want. Let me do that. Let's type the first procedure. So procedure is a keyword, right? So a very good way for you to tell if you actually make any typo on the keyword. If this highlight, that means you did the right thing. Okay. So procedure, let's say ML out, and this procedure here takes no input. So I'll just do anti-pair of parentheses, pretty much like Java. All right. And then the body is going to be enclosed within curly brackets, right? And then and by the way, so for the indentation here, you can either hit a tab space, or you can do maybe 2 or 3 3 space keys. This can be completely up to either do a tab, or you can do several space keys. Either way, right? So what should we do for ML out? It's going to basically the post state value n will be replaced by the pre-state n plus 1. That's what we learned in 3342. And now in a procedure, we're just going to update a variable n, right? Similar. And luckily, we have the same symbol for substitution, like a call and equal. So that's something you don't have to memorize, like a new symbols. So we say n substituted by n plus 1. And here, since we talk about algorithm over here, so you can, for now, you can either interpret this either as a before-after predicate. Remember, n prime is equal to n plus 1. Or you can think about this is more like a variable assignment. Either way would be okay as far as what we are doing the tutorial is concerned. Okay, so of course you can type more comments. So remember, it's going to be something like this. You can think about before, after, predicates or assignments. Okay. Okay, and that will be for n. That'll be for ML out. And there's a very important key thing you want to remember. doesn't matter if the procedure is supposed to return some value or not, right? In Java, you only put the return keyword for accessor if the method actually returns something. But in TLA plus, in Pascal, you have to always do a return. And in this case, since even though we are not really supposed to return some value from the procedure, but we still need to put a return just without returning any value, right? I'll show it to you. Return over here, semicolon. And I'll give you a little look ahead. If you missed this return statement here, you're going to result in some wrong translation when you actually try to translate your Pascal algorithm into the TLA plus. That's something I'll try to see if I can show to you if I remember later. But just remember, you always should put return even nothing. That's required. Okay, so that'll be the first procedure corresponding to our first event ML out. Over here, let's now do ML in. And of course, we haven't got any guard yet. I'll show you how we can encode the guards for the events. So there's some workaround we can actually do in Pascal. And the second one will be, let's say, procedure ML in. No input over here, and enclose the body of the procedure inside the curly brackets. And let me hit the tab. And what would that be? So in this case, n should be assigned to n-1. N assigned to n-1. And make sure you put a return. And also, after each programming statements, you should also put the semicolon like in Java. Okay, don't forget, right? If you're learning a new language, of course, you got to learn about its correct syntax. Otherwise, you're not going to pass the tool check. Return, nothing, and then semicolon. All right, just make sure Control S to save the file. So these will be the two procedures. You can think about they are more like a helper procedures to be invoked in the main program. Okay, I'll put the comments over here. So this will be, let's say, this one here, right? Just remember this slash over here is a backward slash. If you put a forward slash, it will not be treated as a comment. It will not. Okay, so define two helper for procedures call within the main program. All right, so that will be for the two helper procedures. Straightforward. And now, how do we do for the main program? And the main program, we have to enclose it within another pair of curly brackets over here, okay, without any name. So this will be the main program. Okay, sorry, my keyboard is a little bit slow, but anyway, I'll try not to impact it too much. It's my end of problem. So this will be the main program. Main program. And what should the main program do? You want to think about there should be some central controller which will select the execution of either ML out or ML in each time. And then we're going to interleave the ML in and ML out by a number of times. And I'm going to write the program first, and then I'm going to use the bound and also I. So you can see the only difference between our context and also machine or algorithm, the only difference between this and this is the bound constant over here and also the I variable over here. The reason that I introduced these two constructs is because it will be much easier for us to do some bounded model checking, and also it will really correspond to how the central controller will work for selecting for execution either ML out or ML in. That's something we'll see. Let me write it down first, and then I'll try to visualize it. Let's write down the syntax. You can also learn from the syntax. And just don't forget, the main program must be enclosed within this particular curly brackets pair. Okay. And let's say we want to do a loop, right? We want to keep selecting for execution ML out or ML in for how many, for a certain number of times. And that number of times will be parameterized as the bound constant. And the constant is going to be set with some fixed value when we try to create a particular model for the TLA check, right? There are many terminology you may want to put together at the end, but let me just try to go over it with you. So we're going to write a while loop. So this will be similar to how you wrote it how you wrote it in Java and C, the C family language. So here we're going to put some condition under which the loop should really keep executing its body of implementation. So let's say as long as I is, so you can see here we assign initialize I to be 1. You can do 0 if you want to, but let me just say, actually let's do the typical, let's say loop, right? You will start with 0 if you want to, and also strictly less than bound. So you will know that how many iterations should there be for this particular while loop. That should be exactly corresponding to just the value of bound, right? And of course, we're going to set bound to be some value that's meaningful, meaning that it should be strictly larger than 0. That's what we'll do when we create a model. Let me write the notes over here for you. So the number of iteration will be exactly equal to bound, right? And of course, you definitely want to avoid infinite loop. That's what you typically do in Java. You want to do the same thing over here. You want to make sure I will be incremented for every iteration at the end. I plus 1 over here. And what should we do for every iteration? The idea is very straightforward. You can think about the main program over here is a central controller. And the central controller is going to allow either ML out or ML in to happen either way, as long as their guards are actually satisfied. At the moment, the guard is simply true for each one of them, right? Implicit. So let me write it out. So there is a syntax called choice operator. Use the choice operator to simulate the selection of execution by some central controller. Selection of event execution by some central controller. Okay, how do we do it? It's with the syntax either or. Okay, either we do something over here, and I'm going to put something inside the curly brackets, or we do something, and it's going to be over here. Oh, actually, let's put a space inside over here and put a semicolon at the end. All right, let's understand what we have done so far. Basically, this will be some syntax of the following structure. You have to use two keywords, either and or. After the either, you're going to put some updates over here. It could be maybe some procedure call, or it could be some variable assignments, and etc. And also this one here as well, after either and after or. And let's say the first one, for the either, we basically in this case, we either want to do ML out or we want to do ML in, right? So how do we do that? So either we want to select ML out for execution. What's the guarding condition for ML out? Well, implicitly simply just true, right? So but let's write it out explicitly. So you can also use the keyword if. All right, so we say if true, which is the guard of, I believe it should be all capital. Let's give it a try because it's not highlighted. Yeah, that's correct. So really to write a Boolean literal true or false, it needs to be all capitals in TLA plus, but easy to remember. If after you have typed, it's not highlighted, then most likely you should really spell it other way. Okay, so we say if the guard of ML, which is true, is actually satisfied, and then we're going to do something. And then, so that's why we want to enclose by another level of curly brackets over here. Okay, hopefully so far the picture is still clear to you. And what we want to do is we want to invoke this particular event for execution, and we want to invoke by its name. And how do we invoke? And it's not about just to call ML out. I know it makes perfect sense based on your previous programming courses, but unfortunately in TLA plus you will have to write an explicit keyword call over here, right? This is to say if the guard of ML is actually true, in this case true is true, and you're going to call the body of the ML out. right? You can see there's a semicolon over here, and there should be another semicolon. Actually, I'll tell you why. Okay, there should be another semicolon here. This semicolon here, the inner one, corresponds to the call. All right, another semicolon over here corresponds to the if statements. So after the if statement, you should also put a semicolon, right? So that's kind of the little bit of verbose. I can agree, but it's just the syntax for the Pascal that you have to get used to. Hopefully, when you do the lab exercises, you will be able to get yourself more familiar, so that you will be ready to write your own program in the programming test. All right. So this will be the part for ML out. Let's now do the part for ML in, which will be very similar. Let's now do it again. So we're going to say if the guard of MLN is actually true, in this case, the guard of MLN is also true, right? So which will be trivially true. So true, all capitals, and then we're going to do something and put a semicolon for the if statement over here right away. Okay, so you don't forget. And inside the body of the if statements, what should we do? We're going to invoke MLN. And you don't really just write MLN. Sorry. You don't really just write MLN. Let me just put a space back over here so it appears perfectly. So you don't just put MLN and without any only writing this makes perfect sense in your C or Java course, but it wouldn't make sense for Pascal. What you gotta do is you don't want to forget to write the call keyword. You have to do that explicitly. All right, call over here. Right, so we either call ML out or we actually call ML in. So this is a perfect follow-up question for you to ask. Hopefully you're already having that question already. In this case, the guards for these two events are true simultaneously. In that way, which event do we select for execution? Is a fantastic question. Since we are not doing exactly coding, so of course in the Java way or in the C way, whatever that's actually listed first should be executed for execution, right? It's like if something is already satisfied, you will just go for its body rather than going to the next else if, even if the both conditions are satisfied. But now in the case of Pascal, it's more like a design language. So when we say either or over here, if both conditions, or sometimes when we got multiple conditions, if they are satisfied simultaneously, in that way, it's non-deterministic as to which one is actually executed. That's really important. I'm going to write it down over here. Okay. Over here, let me write multi-line comments over here just for us to try. Okay, you can put like that and put a new line first. I would say when multiple conditions are satisfied, it is non-deterministic. Deterministic as to which branch would be executed. In this case, it can be either the branch of ML out is executed or the ML in is executed. All right, it's really important to know that. And that's about it for our program. All right, so I think that will be it for our initial model, right? And what I want to do now is to give you a little bit idea about how to understand the use of the bound and also I. How is that going to help us visualize the tracing of our bridge controller system, the initial model. Let's do that, and then we'll do some property checking. Let me do a little bit of organization just before I take you to my iPad. So I think it might be nice to organize maybe the either or over here a little bit differently by entering more lines, so it might be easier for you to tell where the nested structure should go. Okay, so let's say after either over here, I can hit a new line over here. Oh, sorry, wrong thing. You can do Control Z for undo over here, right? Line number 42 in my case. And you can put a tab over here. And then under the if over here, I can put a new line on the call and then tab. Right, so now you can see more clearly about the structure over here. Maybe that's something I should have done in the first place, but anyway, so now you can see it. It depends on what you really prefer. If you really prefer like the original only 2-line version for the either or, you can go for it. Otherwise, this one is also fine. New lines are usually just ignored by the compiler for the IDE tool, so you don't need to worry about having more new lines than necessary. You can see now very clearly, we got one statement over here with a semicolon. We got some wrapping statement for the if, also with a semicolon. And also we got an either over here. It has no semicolon because it's only the first part of a larger statement for the either or, right? Let's say over here and hit a new line over here, put a tab. And then let's hit a new line over here and put a tab. And let's hit a new line from the closing brackets over here. And just make sure its indentation is aligned with the if. And let's put a final enter over here on the closing brackets. That should be aligned with the or, right? Control S to save everything, right? So that's a program. And it's completely your personal preference as to how much you want to do the new line and try to organize a program maybe a little bit more human readable. I'll leave that to you. Let's now try to use this program over here to explain to you how to really visualize the I and the bound.